Hey everyone, and welcome to The Explainer. Today, we're diving into something that is just absolutely wild. We're looking at Elon Musk's vision for our cosmic future. If you've ever looked up at the night sky and wondered, when are we actually going to become a true spacefaring civilization? Well, you are definitely in the right place. We're going to break down exactly how this massive, ambitious future is being engineered right now, step by step.
But to really get where Musk is trying to take us, we kind of have to zoom out for a second. This isn't just some crazy, isolated idea that popped out of nowhere. It's the next chapter. To truly grasp the magnitude of what's happening in aerospace today, we've got to view it as this thrilling, ongoing saga of human innovation. It's the direct continuation of our ancient, hardwired drive to just explore the unknown. Section 1. A history of space innovation. Let's take a quick look at the massive leaps that laid the foundation for all of this.
Just think about the sheer velocity of human achievement for a second. In 1957, boom, we launched Sputnik, the very first artificial satellite. And then, just 12 years later, in 1969, humanity literally walked on the moon with Apollo 11. It's staggering when you really think about it. Then, by 1981, we've got the Space Shuttle program, which introduced a partially reusable spacecraft. Going from struggling just to hit basic orbit to taking giant leaps on the lunar surface, it was incredibly rapid. It shows exactly what we're capable of when we push the absolute limits of engineering.
But then, we kind of hit a wall, a historical ceiling. Despite all that rapid, exciting history, our expansion into the stars basically stalled out. And it wasn't the lack of engineering talent that killed our space dreams, it was the brutal economics. Imagine building a rocket worth hundreds of millions of dollars, flying it exactly once, and then just letting it burn up or crash into the ocean. Throwing away vehicles after a single use put an enormous, crippling financial burden on exploration. It made going to space this rare, super exclusive event rather than just a routine way to travel.
Which brings us to Section 2, the reusable rocket revolution.
This is the exact moment everything flipped. Musk's vision completely disrupted the industry and shattered that historical ceiling we just talked about. The shift in paradigm is literally night and day. Traditional space travel, it relied on expendable vehicles, astronomical costs, and a painfully slow cadence because you were building a bespoke, highly complex rocket from scratch every single time. But Musk's vision flipped the script. Reusable, cost-effective, rapid relaunch. Instead of tossing the rocket, you fly it, land it, inspect it, fuel it back up, and fly it again. It's a completely dynamic, sustainable model that changes the fundamental economics of leaving planet Earth forever.
So, reusability. It sounds simple, right? Landing and flying these massive orbital boosters over and over to drastically lower the cost of space access. Think about it this way. Imagine if airlines threw away a Boeing 747 after one single flight from New York to London. A plane ticket would cost millions of dollars, nobody would fly. That absolute absurdity was the reality of space travel for half a century. Musk's big realization was that to actually make us a spacefaring civilization, rockets have to operate exactly like commercial airplanes.
Let's talk numbers, because the financial impact here is staggering. We are talking upwards of $18,000 just to put one single kilogram into orbit the old way. Early SpaceX rockets managed to bring that down to around $2,700 by figuring out initial reusability. But the future targets? They're aiming for less than $100 per kilogram. Let that sink in. This isn't just about saving a few bucks. Reusability completely shatters the financial barriers to space exploration. It's the economic key that literally unlocks the rest of the solar system for us.
All right, Section 3, Musk's vision for Mars. With those massive financial barriers finally crumbling, we can look at the ultimate destination these newly affordable rockets are actually built for, the red planet. And the most crucial point here? The distance. 140 million miles. Just wow. That is the staggering, mind-bending average distance between Earth and Mars. It's an almost incomprehensible void. Traveling that far means we have to completely reimagine life support, propulsion, human endurance, the whole shebang. We aren't talking about a quick 3-day hop to the moon anymore. We're talking about months suspended in deep, hostile space.
So how do we actually do it? Well, Musk's roadmap takes this totally sci-fi journey and breaks it down into concrete, engineerable steps. First, you reach Earth orbit with a massive payload. Crucially, you then refuel in space using tanker rockets. Because actually, you can't carry all the fuel you need for Mars straight from the ground, it's too heavy. So you park the ship in orbit, fill it up, and only then do you begin the interplanetary transit, coasting those 140 million miles. Finally, you land on the Martian surface and get to work building.
It takes this seemingly impossible, monumental task and turns it into a logical, step-by-step progression.
But, landing is honestly just a beginning. Surviving Mars, that's a whole different beast. The environment is practically designed to be lethal. You've got deadly solar radiation because Mars doesn't have a strong magnetic field, a dangerously thin atmosphere that's mostly carbon dioxide, freezing temperatures that make Antarctica look like a tropical getaway, and absolutely crucial here, the need for local propellant generation. To get back home or even just keep a colony running, we literally have to synthesize rocket fuel right there on Mars, using water ice and CO2 from the air. The scientific hurdles are just immense.
Moving on to Section 4, a multi-planetary future.
Okay, so we've talked a lot about the how, but what about the why? Why take on these incredibly dangerous, monumental challenges in the first place? Well, for Musk, the ultimate goal is safeguarding the light of consciousness by making humanity a multi-planetary species. His core belief is that right now, all of our eggs are in one planetary basket. Earth is vulnerable, right? Whether it's an asteroid, extreme climate events, whatever. Relying on a single planet means our entire history could be wiped out in a flash. Expanding to other worlds isn't just about exploring for the fun of it. It's literally an essential insurance policy for the human race.
And the wildest part? It doesn't even stop at Mars. Like Musk says, Mars is a stepping stone to the wider solar system. Colonizing the red planet isn't the finish line, it's the starting block. Once we figure out how to survive and thrive on another planet, once we actually build the infrastructure to travel between Earth and Mars routinely, we open the door to the asteroid belt, the moons of Jupiter, Saturn. It's the gateway to an absolutely infinite future of space innovation.
We are literally living in an era where sci-fi is becoming actual history. So I want to leave you with this final, profound thought. Once we cross that 14 million mile gap, what is going to be humanity's next giant leap? Take a moment to think deeply about your own place in this massive cosmic timeline, because the decisions and the mind-blowing innovations happening right now are going to define the future of our species for millennia to come. Thank you so much for joining me for this explainer. Keep looking up and stay intensely curious.